and unpack a meteorological machine that literally dictates the lives of billions of people. Welcome. Today, we are taking a deep dive into the Indian monsoon. It is a massive, continent-spanning phenomenon that is just so much more than a season of heavy rain. But before we pop the hood and look at how this engine actually works, we really have to recognize the stakes here. The monsoon isn't just weather, it's a celebration. It is deeply woven into the subcontinent's food, its clothing, and its vibrant festivals. It's the absolute bedrock of India's socioeconomic stability. When the monsoon performs well, the entire subcontinent thrives. But when it falters, billions of people feel the impact immediately. So here is our roadmap for today. We'll demystify this massive system in 4 steps. 1. The monsoon machine. 2. Gears of the monsoon. 3. Onset. The winds arrive. And 4. The retreating monsoon. Let's start with part 1. The monsoon machine. You know, when most of us hear the word monsoon, we instantly picture torrential, endless rain, right? But derived from the Arabic word mosam, which actually means season of winds, a monsoon is fundamentally a massive, reversing continental wind system. It is literally the climate shifting gears and completely reversing its airflow over the course of a single year. And it's actually a massive 2-part system over the subcontinent. First, you have the southwest monsoon hitting between June and September. This is the really big one that brings the vast bulk of India's annual rainfall. But then you have the northeast monsoon in October and November. These are the retreating winds, and they uniquely drop most of their rain on very specific southern regions like Tamil Nadu. It's just a perfect dual action system. Moving on to part 2, gears of the monsoon. Believe it or not, meteorologists still consider this entire system to be a deeply complex mystery. There is no single tidy mathematical equation for it. But we do have 4 interlocking factors that make up our best modern explanation. We've got differential heating, a shifting pressure belt called the Icse, the heating of the Tibetan Plateau, and high-altitude jet streams. Think of these as the 4 main gears driving the entire engine. So the very first, most fundamental gear is simply the unequal way our planet absorbs heat. Land heats up and cools down way faster than water. During the summer, the Indian landmass gets incredibly hot, which creates this giant low-pressure vacuum. Meanwhile, out over the ocean, it's cooler, so you have higher pressure. Well, nature absolutely abhors a vacuum. That pressure difference acts like a giant pump, forcefully pulling vast amounts of air across the globe, straight from the ocean to the land. Then enter gear number 2, the ITCZ, or the Intertropical Convergence Zone. This is a low-pressure belt near the equator where global trade winds literally crash into each other. But the thing is, it doesn't just stay put. During June and July, this entire low-pressure belt shifts north, right up near the Tibetan Plateau. It acts like a giant magnet, pulling and supercharging those incoming monsoon winds. Now, let's add the Tibetan Plateau into the mix. You can literally think of this intensely basted, high-altitude region in southwestern China as the supercharger of the monsoon engine. From March to June, it just bakes in the sun, creating a massive secondary low-pressure zone. This wildly intensifies the pull, sucking in all those water vapor-laden winds from way out in the distant Indian Ocean. The 4th primary gear, high-altitude jet streams. These are rapidly moving winds traveling in a zigzag from west to east, high up in the atmosphere. Now, their exact mechanical role is still highly debated, but we do know this for sure. When these jet streams withdraw from northern India, it strongly correlates with the monsoon finally starting. It's almost as if the jet streams are a heavy locked door, and their departure swings that door wide open for the advancing winds to rush right in. But of course, no engine runs perfectly without a little outside interference, right? This whole system is highly sensitive to periodic global anomalies. An El Niño event generally weakens the monsoon winds, which can lead to dangerously dry conditions. On the flip side, La Niña actually strengthens those winds. And then you have complex phenomena like the Indian Ocean dipole, which are constantly tweaking and influencing the formation and the retreat of the entire system. And it's not just the Pacific anomalies doing the heavy lifting here. Even something thousands of miles away, like the Mozambique current, plays a massive role. This is a warm ocean current flowing off the coast of Madagascar, right where there's a permanent high-pressure zone. This current essentially loads these traveling winds up with the critical moisture they need. So, by the time they finally reach India, they are totally saturated and ready to unleash torrential rains. Okay, let's take a breath and recap. We've got the pressure gaps, the shifting ITZ magnet, the baking Tibetan supercharger, and the moisture-laden ocean currents. The real question is, with all these incredible gears perfectly aligned, how does the monsoon actually set in? How does this engine roar to life?
Which brings us to part 3, onset. The winds arrive.
Let's trace how this domino effect plays out. Through April and May, intense heat starts carving out that massive low-pressure vacuum on the Tibetan Plateau, while high pressure is just sitting heavy over the southern Indian Ocean. Then, right around June, the ITCZ makes its critical shift northward to roughly 40 degrees north latitude. That is the tipping point. The domino falls, causing the southwest monsoon to violently sweep across the peninsula, dumping vital rains from June straight through September.
Now, what's really fascinating is what actually happens when this colossal wall of wind hits the Indian landmass. It literally splits into two distinct rain-bearing pathways. The first branch sweeps right up from the Bay of Bengal. Meanwhile, the second branch travels parallel to the Western Ghats mountain range over on the west coast. It marches all the way north, carrying those crucial summer rains to Gujarat, Rajasthan, and eventually right into Delhi. Finally, part 4, the retreating monsoon. Because what goes up must come down. As we push into October, temperatures drop across the subcontinent. The land cools down. And remember what we learned earlier? Cooler land means higher pressure. So those immense pressure systems essentially flip. High pressure forms over Tibet, the ITZ shifts back south toward the equator, and the entire engine is thrown into reverse, pulling the winds back down from the landmass and out toward the ocean. Now, you'd probably assume retreating winds are just totally bone dry, since they already dumped all their rain over the summer. Actually, scratch that, there's a really fascinating topographical catch here. As the northeast monsoon retreats, it picks up moisture all over again while crossing the Bay of Bengal. And the unique coastal topography of Tamil Nadu perfectly intercepts these specific winds. It turns what should be a completely dry retreat into a vital, localized rainy season, just for southern India. By the time February and March roll around, the retreat is officially over. The winds have completely settled, the pressure has normalized, and this entire complex cycle is finished. The stage is basically wiped clean, just waiting for the intense summer heat to return and kickstart the whole magnificent machine all over again. It's like a massive continent-spanning respiration that breathes life into the region year after year. Which brings us to our final takeaway for today's explainer. If a completely staggering system, made up of distant plateaus, high-altitude jet streams, global ocean currents, and shifting pressure belts, literally controls the fate, the food supply, and the economy of billions of people, how incredibly vulnerable are we to even the slightest atmospheric changes? It's a pretty sobering thought that definitely leaves you wondering just how fragile this magnificent meteorological engine truly is. Thank you so much for joining me for this deep dive into the Indian monsoon.